Hi everyone. Today I'm gonna discuss about the problems from latest bi-weekly contest E2, and yeah, let's just quickly get started. So I was able to solve three problems. The last one is like difficult to me, and yeah. So let's just quickly solve the problem first. So the problem first is like quite simple. Uh, Wait a second. So the problem first is like you have to evaluate a Boolean binary tree, and the leaf node of the tree indicate true or false, and like all other nodes of the tree indicate an operator, binary operator, or an and. If the value of any node is 2, then the operator is OR, and if the value is 3, then the operator is and true is 1 and false is 0. And basically you have to tell what will be the value of the after evaluating this tree, what will be the final value. So so the idea to solve this problem is simple. Uh, Let me just clear. So suppose you are. Wait a second. So yeah. So suppose you are given a binary tree like this, and here the leaf node represent a true or false value, and true is denoted by 1 and false is denoted by 0, and all the nodes other than leaf nodes are having value 2 or 3, and like 2 represent or operator, and 3 represent and operator. And suppose this is 1, this is 2, and this is 3. So the value of this subtree will be uh, 1, and with 0 is 0. So we will replace this with 0, 0, and then we calculate this expression, and then the result will be 1, or with 0 and the result will be 1. So yeah, you just have to do this and you will get your answer. So what I have done is I had made a function recur, and if the value is like, if you read a leaf node, you just simply return its value, because uh, so so what I'm trying to say, that if the we reach a leaf node, then the expression for this subtree will be value of the leaf node itself. So then you just return the value, and yeah, in this I have taken the val like operator, if the operator is 2 or 3, and left part basically tells the value of left part, like for suppose like we have. So suppose this is an initial tree, then the left will be this and right will be this, and this will be having an operator, and you just perform this operator on these two values. And yeah, I have just done the same process and just simply return the answer. So yeah, that's the solution for problem 2. Let's move to the problem second. So in second problem, you basically given an array of buses and passengers and and a variable capacity. So what does the buses indicate? The buses indicate, like buses array indicate that the ith bus are like the last boarding time for any passenger to board the ith bus is 10, like that value of that index of bus. So what I'm trying to say that suppose a person wants to, suppose like suppose I want to, suppose the value of buses array is n20, and if I want to board a zeroth bus, if I want to board the zeroth bus, then I have to arrive, then my arrival time will be less than equal to 10, or or I can say that bus of 0. So yeah, uh, and the passenger array indicates that the will, so let me just give a second. Yeah, so passenger array tells us about the arrival time of ith passenger, and the capacity of a bus to take, like the bus can carry maximum of 2 persons up. Yeah, so we have to tell the latest time, like the latest time, like uh, if you want, like this will be like quite confusing for many of you, like what does this latest time mean? So latest time, like just search on Google, you will not find anything what is latest time meaning, and you will probably find, so yeah, so something that is most recent, yeah, so the something that is most recent, so like we can say that the recent time we can arrive, so like to catch the bus. So this basically means, like if the deadline to finish some work is, so suppose the deadline to finish some work is 20, then how, like I can say that if the deadline is 20 and I, like I have to do some work, uh, then the, like I am a lazy person, so yeah, so and the deadline is 20, so I have to do this work uh, before or equals to time 20. So I have to tell the latest time, like as late as possible I can do this work, so that the work is completed before or equals to time that is 20. So like this can be quite confusing. So what I'm trying to say that if the deadline to do some work is suppose 20 and I am a lazy person, so uh, like I will try to do my work as late as possible because I am a lazy person. So like what is the time that I can do the work so that it got accepted and its time will not exceed 20. So 20, so I can just finish my work at 20, and this is like the last time which I can finish my work. So hopefully I hope you will get like what I'm trying to say. It became more clear as we go further for the solution. And so yeah, so and you just have to tell the latest time. So in this question, what is the observation is that suppose the array is this 10, 20, and 278, 18 and 19, and suppose 2 is the capacity. So like in my my first bus will depart at 10. So passenger who is having arrival before 10, before or close to 10, then these passenger can simply board this bus and will go. And suppose for the bus which depart at 20, these two passenger will will board this bus and they will go. But for this case, this is the problem that so now the capacity is 2 and I have to board the bus. So I cannot board this bus. I can not simply board this bus, and it is also said in the problem that as if somebody arrives, so the preference of boarding the bus is given to a passenger who arrives early. So uh, whoever arrives early will get a chance to board the bus as early as possible. So yeah, so basically this is the thing. So in this case, I am not able to board any of the bus. So what I am trying to say that if we include these two and try to maximize our answer, so suppose we will try to do like 21. So this cannot be possible because my last bus departure is 20 and like I have to board this bus anyhow. So I cannot, so my value should be greater than this 19. I suppose that you get the thing that if I have to board the last bus and if the passenger like I am the passenger who is trying to board the bus at least time, then what I'm trying to say that my time should be less than this value, the last passenger boarding the bus. So my value should be like should be less than 19. So this can be 17, 18, or maybe 16, and yeah, and so on. So for the latest time, I cannot board the bus at 18 because it is given in the question that two passengers cannot board the bus at the same time. So 17 will be the answer. Yeah. So now you are wondering why 16 is not the answer, because simply 16 is not our latest answer. So yeah. So so what I have what I have done is it's just like a constructive problem. So what I have did is I have assigned the passengers to bus, and so the capacity is 2. So I tried to fill a bus to its maximum capacity. So if the bus departs at 10, then the passengers who arrive before or equals to time at 10, I have assigned them the bus, 0th bus. And in this case I have also done the same thing. And if I had like if I had assigned a bus, like if I had assigned a bus, suppose for 18 and 19, I have assigned a bus at 1th index, and now suppose there is no more buses. So for that case we have to just remove the last element. So the last person uh, who have boarded this bus, and then we have to check for all the previous values. If we can board at that time or not. And if the if we are at, suppose we are at last bus, so last bus departs at 20 and our last passenger is 8, and suppose our capacity is 2 and we only have this one person in our bus, so the answers will be simply 10. But if the last person is suppose 20 or suppose 19, so yeah, and there is no more bus, so what can I say, that I have to board the bus before 90. So yeah, this is the main idea of the the problem. And yeah, so the solution is quite simple. So we first sort buses and passengers, and if like I have stored in a map if the timing of all the passengers, and then I have just simply we will travel in the buses array, and we will just try to if bus of I is greater than equals to arrival time of passenger J, then we can simply like we can simply assign this bus to that passenger. So what I'm trying to say that suppose the departure time is 10 and the arrival is 2 comma 8, then we can assign these two people this bus. So yeah, so I have assigned these two people this bus, and the bus has a capacity cap. And the last and now you are wondering what does this last variable do. So the last variable simply checking for the cases which I have told you earlier. If we are at last bus and I have the full capacity, if I have the full capacity, then I have to remove the last passenger and I have to board train before that person. So yeah, so this is simply tell us that if the last bus is full or not. If the last bus is equals to capacity, so the last bus is full. If the last bus is full, then I have to remove the last placed passenger and then board the train. And if this is not the condition, then simply the answer will be bus of n minus 1. I simply board the last bus, suppose 80 or and the 100, I will board the last bus. This will be the latest time. So then what I have done is, if the answer if this will be our answer, then what I have done is, if I have checked if the if some other passenger also arrive at this time, then this will never be our answer. So what I have did is, I have map, if it is found in our map, then I have answer minus minus and then simply return the answer. So the next problem is minimum sum of square differences. So let me just read problem for you. So in this problem, you are given two array num1 and num2, and the sum of square differences of two array is defined as nums of I minus nums2 of I ka whole square for all the indexes in the array. And you also given two variable k1 and k2, and you can modify each value. So I can modify any value sorry I can modify any value of the array +1 or -1 at most k1 times for nums1, and I can modify nums2 at most k2 times, and each modification I will increase the element by +1 or I can decrease the element by -1. So what this question is all about is, suppose you are given some array 1, 2, 3, 4, 0, 3, 2, 1, and you can modify suppose k1 one time and k2 one time. So the square difference will be this absolute of this difference the whole square, this absolute difference and whole square, and so on. And for the answer you uh, just have to return the minimum value of this sum of square differences. So what I had observed is from the S case, like if we are giving some k1 and k2, then what I can say that I can either increase this value, or I can say I can decrease this value. So if I increase this value and decrease this value, then like what I'm trying to say, that if suppose the values are 2 and 6, suppose at ith index, and I will increase this value by 2 and then decrease this value by 2, then what will be the difference? This will become 4 and this will become 4, so this will be become 0 after k1 is 2, like after consuming k1 2 times and k2 2 times. So what other things, like what I'm trying to say is that I can perform on this element k1 plus k2 operations. Now you wonder why you have, like it is given you can perform k1 operation on nums 1. So if I am performing addition on this, and suppose I have added this element by 3, and if I have decreased this element by 3, then so let me just open my sublime. So suppose I have given like b minus a, and I had simply done is, what I have done is simply I have plus 3 times I perform operation on a, then I have, like this is equivalent to performing 3 operation of minus on b, and then I can, like, so this is definitely equal to this. So yeah, this is I mean when I say that I can perform k1 plus k2 operation on any element of any array. So yeah. So now the question arrives, like how we will decrease these values and like try to calculate answer. So the another thing that I observe is, suppose I have given 1 and 4 and 1 and 5, sorry, and this is given like 4 and 8. So and if the k1 is 2 and k2 is also 2, so suppose yeah, this will be like very like for it, so 2 1 1 and this also 1. So so suppose I have, so what I'm trying to say that if I perform these, like an operation on this index of k1 and k2, then suppose I have increased this value by 1, so this will become 2, and suppose I also perform decrement operation on this will become 4, and this will remain 4, this will remain 8, then the answer will be 2 pi square 4 and 4 pi square 16, and value will be simply 20. And suppose I performed the operation on this one only, like both operations on this one indexes, then you will see that, so this will become 16 and this will become 5 and this will become 7, so this will become 2 and this will be again 20. So yeah, so what other things I can do is I can perform one operation on this element and one operation on this element. So so, so 1 5 4 and 1 1, this is capacity. I hope you will understand that. So I will perform one operation on this element. This will become 2, this will remain 5, and this is 4, and this is, so decrement operator, and this is, so the decrement of this by 1 is equivalent to increasing this by 1. Like I can say that, yeah, I can say that. So now the answer will be 3 square 9, and again 3 square 9 and 18. So what I have seen is that if I perform an operation on two different indexes, then this will give a minimum answer. Right? Like how you can say that, like what are those indexes where you will decrease and increase. So definitely I will perform operation on those indexes in which the difference is maximum. So in this case the difference is 4 and difference is 4. So no need to worry, you can perform one operation on this, then the difference will decrease by 1 and this will remain 4. Then maximum value will be 4, and then again we will decrease 8 to 7, and the value will be, difference value will be 3. So yeah, these are the operations, but like performing, like pushing all the values n values into the priority queue and then just copying one value and this priority queue definitely store values according to nums1 minus num2 absolute value. So what I'm trying to say is that we can perform this question by just maintaining a priority queue which tells the maximum absolute difference. Suppose this is 3 and this is 5 and this is 2, then this is 8, then this, the difference is 6 and this is 5. So I can perform operation of this index and definitely increase it to 3, and then the difference will be 5, and then I can perform operation on any of this or this because the maximum difference is 5 now. So yeah, but the problem with this approach is that it will give a tail. Suppose you encounter a case where the values are 10 raised to the power 5 in worst case, and this is 0. This is 10 raised to the power 5 and this is 0. And suppose the case value was 10 to the power 9 and 10 raised to the power 9. So if I decrement this by 1, then this will become 10 raised to the power 5 minus 1, and k value will decrease by 1, and then this value will come. So this loop will run 10 raised to the power 9 times. So what I can smartly do is, suppose I have these values, then these absolute difference will be 10 raised to the power 5 and 10 raised to the power 5. So the value with same absolute differences, instead of decrementing -1 of individual indexes, what I can say that I can decrease 2, right? If the k is like any number, then if I can perform, like suppose the k is 3, so I can perform -1 and -1 on these two elements, right? So yeah, so this will save us from TLE, and I will decrement simultaneously. So if the elements are having equals same differences, same absolute differences, then instead of individually decreasing by 1, uh, I can decrease 3. I can decrease 3. So this will become 9, this will become 9, and this will become 9. And again 9 is the maximum frequency, and again we will try to decrement all these three values if I have enough k, and otherwise we will not. I think hopefully you get this, and you also get what I am trying to say when I said that this will give TLE if I try to individually decrement the values, because every time we will decrement the maximum absolute differences, and in worst case it will give us TLE. So yeah, so like this part you can ignore. So this has to nothing to do with the solution, and yeah, and this part also has nothing to do with the solution. And then I have just taken map and then stored the absolute differences, and then I have value, and I told you before that suppose this is 2 and this is 8, and we are given like 1 and 2. So increment this or decrement this, both are equivalent. So yeah, like I told you this. So that's why I have a k1 plus k2 operations, and while have and while m is not empty, so the maximum index will be, so the maximum will be at the last of the map. So I have assigned the iterator to this, and value is the, like, value denotes the absolute difference. Suppose in this case this will denote 10, and this will denote 10, and this will denote the frequency, like how many times our 10 absolute difference 10 arrives. So in this case it is 3. And what I have said that if I have like, if I have enough operation to decrease all these values by 1, then the our having operate have should be greater than equal to this frequency is greater than equal to 3. So yeah, so if this is the thing, then I can decrement all these absolute differences by 1, and then again become 9, and frequency remains same 3. So yeah, so I have done this. If then I have plus mp of p minus 1 plus is equals to x. So why this? Because suppose 9 is already present and we have performed operation on these 3, then our 9 value will be 4. I hope you got this. And yeah, if I do not have enough operations, then I can just simply do is like the operation is over, and yeah, so the answer will be absolute differences square and how many times they appear into the map, and then just simply find the answer. So yeah, this is the solution. Now the next problem is subarray with elements greater than varying threshold. So this is the question I was not able to do during the contest. Yeah, so let's just quickly solve this problem. So this is a quite interesting problem. So in this problem, you are given an integer array nums and an integer threshold. Find any subarray nums of length k such that every element in the array is greater than threshold divided by k, where k is the length of that subarray. Return the size of any such subarray. If there is no such subarray, return -1. Subarray is continuous, non-empty sequence of element within an array. So yeah, this is the definition of subarray. And so let me just quickly tell you what is the problem is. So problem is given a threshold, suppose x, then and you have to like tell the size of array such that every value should be greater than threshold. So yeah, so let's just try to think of this as a point of view from mathematics. So suppose this is the element I of the subarray. Suppose we have find an answer. So then the element of subarray should be greater than threshold divided by len. Len is the subarray length. Suppose we have already find the answer. Suppose we have find an answer and the length of subarray is 4. Suppose x, and then whatever. So if the len is x, then the every element of this subarray should be greater than this value. This value for every element of subarray. This value should hold, and what I can say that if this value should also hold for my smallest element. This value should hold for our smallest element. So yeah, threshold divided by length. So this should also hold for smallest element. So if the value hold for smallest element, then the our value should also hold for elements that are greater than smallest. So what I am trying to say that if the subarray is 3, 3, 4, 5 and we have already find, suppose this is our answer subarray, and we have already find it that then 3 will be our minimum element. So if this is our answer, then what is the condition to say that this is our answer? So we can say that if smallest element is greater than threshold divided by length, then we will get our answer. We will get our answer as that. So what we will do is that we will try to say that suppose the elements are 1, 3, 4 and some random. Yeah. Suppose this is our minimum element of the subarray. So in this subarray, I can include all the values that are greater than this, and I cannot include values that are less than this, because this is our smallest element in our answer subarray. So if I have included this element, then what will be the length of our subarray? So from this equation, if I shift len to the LHS side, then the equation will become len should be greater than threshold divided by element. This should be true. So yeah, so in this question we will try to take every element as the minimum element, and then we will find this value, and if this value is greater than uh, the sub array, then this will be our answer. What I am trying to say that for 4, suppose I have some sub array, suppose some sub array in which 4 is our smallest element. So what can be the sub array? So sub array can from here to here. Then this will have length 4 and thresh. So length should be 4, and suppose threshold is 10. Then our value will be 10 divided by 4. Then this will be 2.5. So every value should be greater than 2.5, and from this equation I can say that if this is our smallest element and the length is 4, then what will be our threshold value? So like what will be our value of sub array length such that this value can be included? So this will be threshold divided by uh, current element. So our subarray size should be greater than this value. So yeah, so now what I have done is, suppose we are given element like this 1, 2 and 4, then we are doing 3 and 1. So for 2, suppose in some subarray the 2 appears, like 2 appears, then for larger values our threshold will definitely hold. So what I am trying to say is that if I have some subarray in which 2 is the smallest element, so that subarray can have length from 2 to, like from here to here, and if the length is 3. So yeah, so then the threshold value will be and the value will be threshold by length, and the smallest value of our subarray should be greater than this value. Then our answer will be length, and the vice versa is also true. I can say that okay, val is equals to so I can say that length of subarray should be greater than threshold divided by our current subarray smallest element. So this should at least be the size of subarray that has 2 as our minimum element. At least this should be the size, and we will calculate the size using next smaller element and next greater than element, and then we will do the question. So like how to open this question in this question. So yeah, so what we were trying to do is, suppose this is our array. So what we, so if 2 is our smallest element in any array, then I can include 2, 4, 3 in our, like this will be the maximum length that I can include. And then what I will try to check is that if this length is enough, for the value, so value will be, so I have tried that, I have said that this equation should hold if the minimum element is 2. This equation should hold. So our minimum length of the subarray should be, so our our threshold length should be less than our this like maximum subarray in which 2 is our smallest element. So yeah, so now I have calculated the maximum length subarray with in which the 2 is the smallest element. So now our main concern is to found a subarray length in which 2 is our smallest element and all other values are greater than or equal to 2. So for this I have used uh, next smaller concept. So for 2 next smaller is 1. So I can include all these values before 1, and so in this case the next previous smallest is 1. I cannot include any element because there is no element between. So I have calculated next smaller and previous smaller. Then the length will be next smaller minus previous smaller minus 1. So this is at 0, 1, 2, 3, 4. So this will be 4 minus 0 minus 1 length. And if this length is greater than our threshold length, the threshold length will be like this threshold value, threshold minus, so sorry, divide by this smallest value, like this is coming from here side, like this should hold, and if I just transfer ln to LHS, then this will become this, and then so wait a second. So suppose this is the minimum length. So we called it as minimum length. So minimum length of thread. But this, then the length should be greater than min length. So this is required, and this we have current length. So this is meant by this. So current length will be 3 and required will be suppose x, then 3 should be greater than x. Then we will just simply return that answer. So for this concept I have used next smaller and next greater. And yeah, in this part I have calculated next smaller element, and in this I have calculated so what I'm trying to say is that suppose I have 1, 2, 3, and 2, 4, 1, then the next smaller of this in like, so what is next smaller is index of the element whose index is greater than this element index and which is smaller than this element. So this is 1. So I have stored 0, 1, 2, 3, 4, 5 here, and in previous smaller I meant by this one. So in this previous smaller I have stored index which are smaller than this index and whose value is smaller than this value. So in this case next smaller will be suppose this is the value will be 1, or I have stored 0 here. Then the simply the maximum length then we can have is, okay, so I had made a mistake. So this next smaller will be 2, but let's just modify this to 5. So then I'm really sorry for this, and yeah, then the length of the subarray will be 4, and this 4 should be greater than our minimum length. So yeah, this I have calculated here, and then I have calculated length, and this then the current value, like the minimum length. So this minimum length should be less than our available length, and if this is the case, then I have written the length. And yeah, if I have not find any length, then just return -1. So I hope you understand the solution, and yeah, that's it for today.